Hi, I wanted to put together an answer to essential question number 2, version 1 during the fall of 2011. And this is the first that you'll see during the year of those that you're trying to figure out what factor notation is in these cash flows. So let's start with where you should think about breaking this into parts. What I'm doing here is noticing that we've got a couple of different choices, and what I'm going to choose to do is take this segment over here on the left and treat that first. To me, this is something which looks like it's supposed to be a geometric gradient. You see it starts at 2, and then it doubles, and then it doubles, and it doubles. So it's a perfect example of a geometric gradient, it's just not exactly in the right place. The first time we see a value is in time period 3 and not back here on time period 1 where it's supposed to go. So we're going to have to deal with some time shifting. And the other half of it over here, the part from time period 7, 8, 9, 10, and 11, this looks to be something that's like a linear gradient. In each case it goes down by 3, but you see instead of starting at 0 it starts at 13, which means we have to think of it as having a constant series that is 13 high, and then we're subtracting chunks off it each time. So let's get this present value in factor notation running, starting with this first chunk right here. What we have is an initial value of 2, that's what that guy is right there. We are looking for p, given that we know a sub 1, that's how you write those geometric gradients. And what we have it here is it has a growth rate of 100%, and the n on it is 1, 2, 3, 4. Okay, so that would give us the present value of a geometric sequence that started in time period 1 and then went on out to time period 4. Well, that's not exactly what we have. We've got one that starts over here with its first value in time period 3. So in order to fix that, we've got to do a little bit of shifting. And so I'm just adding in this part at the bottom and reminding you of this old little counting rule. And the old little counting rule works like this. If you look at the last time period where you see a value in that sequence, in this case it's a 6, it should equal to the sum of the n that you have over here in the sequence and the exponent that's down there on the time shift component. So 4 and the 2 should work out. So what we're seeing is that this thing right here in the numerator takes all the value, dumps it in time period 2. This denominator down here takes everything, moves it from time period 2 to time period 0. Easy. So let's go ahead and get the other part of it over here, this part on the far right. And what we're doing with this one is we're starting with this constant series that's 13 high. So we're looking for p, given that we know a. It's different from a sub 1. Whatever the interest is, I don't really care at this point because I'm just aiming for factor notation. And it is 1, 2, 3, 4, 5 long. Okay. And we know it has to be time shifted because it doesn't start in time period 1 like it's supposed to. But if you go ahead and use the trick, you notice the last time you see one of these 13 highs, it's in time period 11. So we know that the 6 here would work just fine. And if you think about it, the numerator takes everything, drags it over to time period 6, all these bits and pieces, and the denominator drags it from time period 6 all the way back to time period 0. So that's the first part, the 13s that are across. Now from there, what we're going to do is we're going to subtract off a linear gradient. So we're looking at something which, if you see, it goes down by 3, 3, 3, 3. So it goes down by 3 each time, and that's what you should have to the left on the linear gradient. We're looking for p, given that we know cap g. So the thing on the right indicates, the thing to the right of the slash indicates what's to the left of the parentheses right there. Whatever the interest rate is, and now let's go ahead and count the items we have to worry about, where there's 1 drop, 2, 3, 4, and then we add 1 for the pot. And that's the rule you have to remember with the linear gradient, because the time period 1 that's there for it always is supposed to be a 0. Now let's go ahead and do a little time shifting. And again, it should be a 6, since 5 and 6 together add up to 11, and that's the last time period you'll see an element of linear gradient. So there it is. One way of writing in factor notation the cash flow sequence for essential question 2, version 1 in the fall of 2011.